zero. It's okay because in redox you have reduction, but you also have oxidation, so the zeros cancel each other out. The arbitrary zeros cancel each other. The errors cancel each other out. This is the net effect. E of the cell is equal to the oxidation potential plus the reduction potential. And so the effect of the arbitrary zeros is cancel each other out. This is absolute zero. Absolute zero means that when your battery goes to 0 volts, it means it's completely dead. Although your home batteries, they probably won't go to 0 volts because electronic equipment has a certain minimum voltage required to operate it. And so they aren't completely dead. But 0 volts would be completely dead. There's no force pushing the electrons through. 0 volts means that this cell's at equilibrium. And so that's absolute zero. This is true. The battery is dead. Which is the larger reduction potential? 0.05 volts or minus 2.12 volts? B? Anybody pick A? A is correct. A is this is 0.05 volts stronger than, is a reduction potential, so it's stronger than H plus. This is a 0.05 volts better oxidizer than H plus. This is minus 2.12 volts worse than H plus. So minus 2.12 volts worse oxidizer than H plus. We could see that here. If you want, so, although it's not here, something about 0.05 volts better oxidizer than H plus would be something like silver bromide would be a little bit better oxidizer than H plus. And something that's minus 2.2 volts worse than H plus would be comparable to magnesium ion. Magnesium ion is 2.4 volts worse than H plus as an oxidizer. And so that's what that means there. And so the answer is A. 3, which is the larger E of the cell? A, how many people chose A? You can change your answer now if you want. How many people chose B? The correct answer is B. B is the larger cell potential. It's just that the person who hooked up the voltmeter or the person who did the cell hooked it up backwards. You know, they put the positive on the wrong terminal because what this is saying, negative 1.1 volts is saying the electrons are being pushed backwards. Well, that means you hooked up the voltmeter backwards, right? All you have to do is hook the voltmeter up in the right way, and this is going to turn into positive 1.1 volts. Because you must have missed a sign. You hooked it up to the wrong terminal, not the anode, but the cathode. And so this is the difference between a cell potential, which is a full potential, and half potentials. Half potentials are reduction potentials and oxidation potentials. Reduction potentials and oxidation potentials are arbitrary zero. They're like Celsius. Cell potentials are absolute zeros like Kelvin. And so if you have a, this negative means electrons are trying to flow backwards in your voltmeter. This negative, does it mean the electrons are trying to flow backwards? No. This negative means that you're weaker than the SHE. The potential for 2H plus, 2 molar plus 2 electrons goes to H2 gas at 1 bar is equal to 0 volts, greater than 0 volts, less than 0 volts, or cannot be determined. So how many people chose A? A is wrong. Why is A wrong? A would be correct if I made one change. A is correct if I just changed what? No? If I change this to 1 molar, then I'm right. Because the definition, that arbitrary 0 is not for any H plus, that's for H plus under standard conditions. If all of a sudden I double the concentration, what's going to happen to the pulling power? It's going to go up, right? And so that means that the correct answer is B. It should have greater than 0 volts reduction potential. Oh, did I skip 4? Okay, sorry. I skipped 4. Let's do 4. For iron 3 plus 1 molar plus an electron yields iron 2 plus 1 molar. E is A, E naught, B, less than E naught, C, greater than E naught, or cannot determine. The answer is C. The answer is A. A, because this is just under standard conditions, so this potential must be a standard potential. This is a standard reduction potential. The correct answer is A. 6, an E naught oxidation less than 0 volts means oxidation is non-spontaneous. So if we have an oxidation potential that's negative, does that mean it's non-spontaneous? Is that what it means? And so is that true or false? Okay, false. I didn't hear any truth. False is correct. We don't know if oxidation is spontaneous or non-spontaneous because it depends on the other potential. What's the other potential? We can't have oxidation without reduction. And at the reduction potential, we have the oxidizing agent. So we don't know if it's going to be oxidized or not. It depends on the strength of the oxidizer. The strength of the oxidizer is going to be given by the reduction potential, but there's nothing said about the reduction potential. So we have no idea what the reduction potential is, so we cannot determine if it's going to be oxidized or not. Eight, I haven't talked about. 9, I haven't. 10, I haven't. 11, I have. Uh-huh.
Can you do 7?
Oh, did I skip 7? Oh, yeah, I skipped 7. Oxidation potential, the way we read this is standard oxidation potential. Standard oxidation potential. Standard oxidation potential less than 0 volts means the reverse reaction is spontaneous. This was supposed to be true or false, sorry. Is it true or false? Reverse reaction is spontaneous. So if we have an oxidation potential less than 0, does that mean the reverse reaction is spontaneous? No. And so this is false. Oxidation. So look at 11 and 12. We should be able to do 11, 12, and actually we should be able to do 13. Cool. 11, 12, 13, 14. Actually, we should be able to do 11, 12, 13, 14, and 15. So try those. Let's just look at 11, 12, 13 right now.